Hey guys, I wanted to do just a quick video on solving exponential and logarithmic equations. In the first video, in part one, we're mainly going to be focusing on the exponential part. So to do this, we need just kind of a theorem, if you will, basically that says that if I have some a to the b power equals d, then I can rewrite d to the c power as a to the b power to the c power, or a to the bc. I promise you I'll make that make sense. All right, so let's go. So the first thing that we want to look at here, we want to look at this problem that's 2 to the x equals 8 to the third. All right, and here's how you deal with this. So what you want to do, the main thing that I'm trying to do is you want the basis to be equal. That's my main focus here, is I want these bases to be equal. Okay, well I have 2 to the x. What base could I change this 8 to? Well, 8, let's remember that 8 is 2 cubed, so that the bases can be the same. I'm going to change this 8 to be 2 cubed. So we're going to go 2 to the x equals 2 cubed. Right? All we did is we changed 8 to be 2 cubed. Now that means then that 2 to the x equals 2 to the 9th power. Now let's think about it. If the bases are the same, then we know that the exponents have to be the same. Therefore, x equals 9. And it's as simple as that. Let's do this problem over here. So we got 9 to the 2x minus 1 equals 3 to the 6x. We can change 9. I'm going to do that kind of to the side. We can change 9 to be 3 squared, can we not? So we can take this 9 and replace it with 3 squared. To the 6x. Okay. Now that we've done that, what we can do is we can now multiply out or distribute this 2 to this whole thing. So this is going to give us 3 to the 4x minus 2 equals 3 to the 6x. Now that we've done that, we can say, oh, okay, I have the same base, therefore my exponents must be equal. So I now have 4x minus 2 equals 6x. Now from there, I then can, I can subtract 4x from both sides. So I'm going to do that real quick. That gives me positive 2x on this side. You divide everything by 2, you end up with x equals negative 1. So those are my answers here. You can see how simple that is. All right, another type of problem we're going to have is what's called a compound interest problem. And let me explain what compound interest is. So let's say that you wanted to, let's say you were heavily investing and you wanted to put $100 into, you want to put your $100 into this bank. And you have a ridiculous savings rate of 20%. So the bank has savings of 20%. Annually. Okay, we put $100 into this bank, savings 20% annually. The only place you can get 20% is probably Vegas, to be totally honest. But let's think about, we're saving at 20% annually. Let's think about year one. In year one, or actually even before year one, let's think about year 0. So when you first, I think about year 0, mainly is my principal. So I first put in $100. After 1 year at 20%, what is 20% of 100? That's right, it's $20. So in year 2, I'm not going to have just $100. I'm going to have $120. Okay. Now let's say I don't touch this, I don't take anything out, and I leave it in. How much am I going to have in year 2? Well, I'm not going to make 20% savings, or I'm going to make 20% savings. I'm not going to make $20 on this money. I'm going to find out, I'm going to make 20% on $120. Not 20% on $100, but 20% on $120. And what's 20% on $120? That's right, it's $24. So I'm going to take this $120 and I'm going to add $24 to that. And in year 2, I'm going to have $144. And if I do it again and I don't touch it and I'm making 20% on my money, in year 3, I'm not going to do 20% of 120, not 20% of 100. I'm doing 20% of 144. And 20% of 144, you guessed it, is $28.80 basically. So you add that to this, and now all of a sudden I've got $172.80. Notice in 3 years, I've almost completely doubled. And next year, indeed, I will have doubled, pretty much doubled my my initial investment. This shows compound interest. Think of compound interest as being like you got like a little snowball, right? And it continues to roll down a hill, picking up more snow and getting bigger and bigger and bigger till it becomes a really, 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 really big ball. Okay, that's what compound interest is. It continues to grow and grow and grow. So let's do a couple of problems with compound interest. Now there's a formula for compound interest. We're not going to get into what the formula is, but we are going to talk about just a few things about this formula. So the first thing is the formula is A, which is your amount, total amount, this total amount, is the P principal times 1 plus R, which is your rate, N, which is number of times your interest is compounded, and T is time in years. Okay, so once again, A is your amount, P is your principal, is what you put in. Like in the first example, our principal would have been $100. R is your rate. In the first example, my rate was 20%, or in decimals is 0.2. N is number of times interest was compounded. In my original example, we compounded interest every year. And T, so 1 would be your number of times compounded. And T is your time in years. So like year 1, year 2, year 3, and so on and so forth. So let's do a problem. An investment account pays 4.2% annual interest compounded. That's not a really great investment unless it's like an annuity or something, I suppose. If $2,500 is invested in this account, what will be the balance after 15 years? All right, this is a great question. So once again, let's see if we can remember what our formula is. Well, our formula was A equals principal times 1 plus R over N to the NT. Now we're going to just plug and chug all of the things that we want. Now remember, what are we trying to find? What will be the balance after 15 years? So we're trying to find A in this case. That means we must be given everything else. All right, well, what's our principal? $2,500. So P in this case is $2,500. And 1 plus, what's the rate? Well, the rate is 4.2%. Now remember, you need to move the decimal place over 2 spaces to the left, right? You're gonna move it 2 spaces over to the left. So this is gonna be really, R is really, in this case, 0.042, okay? Now, N is the number of times interest is compounded. Well, we're told that interest was compounded monthly. So how many times per year is interest compounded if it's compounded monthly? That's right, it's 12. So if you put, for N is gonna be 12. So once again, we're gonna fill in 12 right here, 12 right here. You see, I'm just filling in the blanks, right? I'm just filling in all this stuff. And then time in years was 15. All right. So we got all of this information down. So let's see if we can plug it into our calculator real quick. So just go into our calculator, and this is great because you can you have a calculator like this, you can kind of set up your calculator to, actually let's put it over here. You can set up your calculator to do these calculations for you over and over again. So let's see, we're gonna have 2,500 times 1 plus, I'm gonna put this in parentheses, 0.042 divided by 12. Let's see, double close parentheses, because we're gonna take this to the 12 times 15. So sure. And we get 4,672. Yeah, sounds right. All right. So we've got 4,688.87. Okay. And sounds right to me. Yep. All right. Cool. And that's the answer. Probably should put, I'll just put it over here. 4,887. Okay. And that's how you do compound interest problems. It's really that simple. Now, the last thing I want to talk about is solving exponential inequalities, which basically is the exact same thing. Only difference now is that you deal with the inequality versus dealing with just a number. And to deal with this, basically we once again need to find a similar base. So 8 and 16 both could have a base of 2. How do I know that? Because 2 cubed is 8 and 2 to the 4th is 16. Right? So now I can just replace 8 and 16 with these 2 cubed and 2 fourths. So I got 2 to the 4th. I got that 2 to the 2x minus 3 less than 2 to the 3rd, which gives me, now we got 2 to the 8x minus 12 less than 2 to the 3rd. And just like, before, we can just replace now with 8x minus 12 must be less than 3, right? If the bases are the same, this must be true. We then go 8x less than what? We add 12 to both sides is 15. So x has to be less than 15 over 8, which 15 over 8 is about, so it's like x less than what, 1 point, let's do it real quick. 1.875, yeah. And that's how you do it. I mean, it's really that simple. Let's do this one. 1 over 243. Something not as well known, obviously, but you can always put it into your calculator. You're not quite sure about 243, but you have a hunch that's probably going to be 3 something. So let's just do 3 times 3. We know that's 9 times 3. We know that's 27, but let's keep going. Let's do one more. Okay, 81. All right, that's 4. Okay, 5. So this must be 3 to the 5. But remember, it's 1 over 243, so it must be 3 to the negative 5. Okay, so now we're going to just replace this with 3 to the negative 5. So we've got 3 to the 2x minus 1 less than or equal to 3 to the negative 5. All right. So now, I mean, it's real simple. We can just set these equal to each other. So you get 2x, 1 greater than or equal to negative 5. If you, of course, add 1 to both sides, you end up with 2x greater than or equal to negative 4. So you get x greater than or equal to negative 2. Now, remember, the only time you flip the sign is if you divide or multiply by a negative number. And notice 2x was not negative, so we didn't have to flip the sign. All right, that's it. I hope you enjoyed the session. Don't forget to like, subscribe, do all of the things. I'll see you in the next video.